Good morning, everybody.
Good morning.
Come on. There you go. Good morning, everybody. All right, that's pretty good. The weather feels warmer today, so I'm feeling a bit energized by that. But I just wanted to say thank you, first of all, to Nick and welcoming me here to open the meeting today, and welcome to the 27th NIH Tissue Chip Consortium meeting. I want to thank you all for joining us for this sort of gathering today. It's a testament to the partnerships that we've been building over the past several years, and especially with the Critical Path Institute's Complex In Vitro Models Qualification Framework workshops. And I just want to thank Nick for his leadership and organization in bringing us together today too. It's really wonderful to see so many members of the community here today. I know many of you, and I've been meeting many of you as well. And I just want to also begin by thanking the many teams who make this consortium what it is. Nick had a great slide of the people. I didn't actually prepare slides, so I'm just going to say a few names and probably miss a few people. But I just wanted to thank the teams, our translational centers for MPS, the groups advancing the neuromuscular junction tissue chips for botulinum potency testing, our Tissue Chips in Space 2.0 investigators, and the many NIH-supported researchers who have contributed to this program over the years. And I also want to acknowledge our FDA colleagues as well, our partners from industry, our NIH collaborators from the Common Fund and across the different ICs that I also think we hold very dear to the real power behind this consortium. And then all of the colleagues, of course, across the federal government. Programs like this only succeed because of the strength of those partnerships behind them and the collaborations that we build through them. And I think that this being the 27th Tissue Chip Consortium meeting was really a testament to those strong collaborations that we're building and we're continuing to build. The Critical Path Institute has been a leader in advancing innovation and really innovative approaches to drug development. And this has helped to shape the community together around this sort of shared goal of improving how we evaluate therapies and accelerate the path from discovery to patients. And lastly, I think with the Critical Path Institute in organizing this meeting, I also want to thank very specifically Christine Apple, Pasley Hargrove, and Dimitri Krupke for their leadership in this space and for organizing this event here today at NCATS. So I really, I'd love to give everyone that I just mentioned a round of applause because that includes you. So thank yourself. Thank you so much for coming today. So over the past year, we've seen renowned and renewed commitment to the idea of what these new approach methodologies are and what they need to be. And that's included the leadership from the NIH, from the FDA, from the EPA. And this renewed sort of commitment is complementing our approach to how we complement animal models, how we might even one day replace traditional animal models in biomedical research. And these approaches are really essential if we want to actually modernize drug development and truly fulfill the mission of turning discovery into health. And since this program began in 2012, the NIH Tissue Chip program has supported pioneering work to build human-relevant microphysiological systems that can model disease, it can predict toxicity, it can test therapeutic efficacy, and perhaps even build or enable more personalized approaches to medicine. And we're seeing that being done today. And what's been, I think, especially exciting over the last couple of years is how this work is moving from not just the innovation stages, but actually more towards the real-world use of these applications. I spend some of my spare time doing astrophotography. It's something that really does keep me up at night. But to the naked eye, the night sky is mostly points of light. When you ever look up at the sky, you see a lot of stars. But with the right instruments and enough patience to gather the light, those hidden structures start to appear. the nebula, the galaxies, and the systems we didn't really know were there. And so tissue chips to me are doing something very similar for the biology. They're giving us new lenses on human physiology. These are approaches that complement the traditional models, and in some cases, they allow us to move beyond them. So helping us see those diseases and therapeutic responses in ways that we weren't able to do before, that I think is really exciting to me, and why I'm really very supportive and excited about this program. Through the TraCE-MPS program, we're working to accelerate the translation of these models into drug development by advancing those more mature systems through regulatory qualification, including the FDA's iSTAND program, so that they can become trusted tools used by industry. And another powerful example of this partnership is the botulinum toxin potency assay program, or the BOT patch program. NCATS and the FDA are partnering to develop tissue chip-based assays that could replace mouse lethality bioassays that are still used worldwide. This is an assay that really needs innovation like this. Hundreds of thousands of mice are sacrificed every year for this testing, and advancing reliable human-based models is not only scientifically important, it's also a meaningful step in terms of the steps forward that we can take in the ethical management of the science that we support. And then finally, one of the most ambitious frontiers of this program is the NCATS Tissue Chips in Space program, in partnership with NASA, CASIS, NIA, and ORWH. This program is the unique sort of environment uses the unique environment of microgravity to accelerate our understanding of aging and disease by sending these complex automated microphysiological systems into space. We can study these biological processes in ways that they unfold much faster than in space than they do here on Earth, helping us to uncover mechanisms of disease and identify potential interventions that could improve health here at home. It's really, I think, one of the most, maybe not the most, but is one of the most extraordinary examples of how bold ideas, interdisciplinary science, and strong partnerships can open entirely new avenues for discovery that we're trying to do here. The work represented in this room reflects more than a decade of progress, but also very enormous potential for what comes next. And so I think that together, this community that's here in this room is helping reshape how we study human biology, how we think about developing medicines, and ultimately how we even better deliver more precise treatments to patients. So I want to thank you all for your dedication, your creativity, your collaboration that you bring to this effort. And I think with that, I'm really delighted to welcome you to this meeting. I'm going to be on the main campus for most of today, unfortunately, so I won't be able to hear a lot of the discussions, but I look forward to hearing from Christine, Dimitri, and Pasley about the discussions that do take place. So for all of you here today, I just ask that while you're here, use this meeting to be bold and creative. Think about the future of this program and the future of this field. Where do you want this to be in a year? Where do you want it to be in 5 years? And make it happen. This is the time where we can make big leaps, because there's a lot of really support and excitement around this particular field. And so this is the time to do great things. So I really appreciate you being here, and I look forward to the outcomes of the meeting. Thanks so much.